Okay, let's try a mock assessment. Right, let's look at the first question. You are given an array prices where prices of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return zero. So it's I think the basic question around the basically we want to buy at the for every day we want to see what's the maximum profit I can get if I buy on that day, right? Which would be if we quickly look at the whiteboard and the example that is given to us, which is 715364. So the idea is I buy on one day and I sell another day, right? So what I really need is if I am buying today, what will I sell at? I can sell at right max, right? I have to find what is the maximum value in my right. So if I buy at 7, either that or it would be something that I sell if I'm going from right to left to right. If I'm this point, then I want to see what is the left min. So right max is where I want to buy or I want to sell. Sorry about that. And left min is where I want to sell. I want to buy, right? So I'm going to look at this instead because I want to travel left to right. For every node, I will see if I am selling today, that means I bought in one of these and I will have bought the one which is minimum. So I'll keep track of minimum and that will help me in the decision for the maximum profit that I can get. All right, so let's implement that logic. So we're gonna do profit as 0. We're gonna take min as integer dot, or actually we can initialize min to prices of 0, right? And then we go I equals to 1, I less than prices dot length, I plus plus. What will be the profit? So profit would be math.max profit, comma, if you're selling on this day, which is prices of I, then the profit would be prices of I minus min, right? Because we would have bought at this point, and then you're gonna do min equals to math.min of min, comma, prices of I. So you keep track of minimum like that, keep track of profit like that, and you return the profit. That's my solution. Let's run and see. 5 and 0 are the two examples. Okay, let's look at the second example also passes or not. 5 and 0 we do. So let's submit and see if all test cases pass. And they do. Let's move to the second question. Oh, okay. So second question is you're given array prices where prices of I is the price of the given stock on the ith day. Find the maximum profit you can achieve. You may complete at most 2 transactions. You may not engage in multiple transactions simultaneously. Okay, so the difference between this question and the previous question is that uh, you can do 2 transactions. There we could only do 1 transaction, right? Now there are 2 transactions. So how do we handle that? All right, so we'll do some sort of a DP here. I'm gonna clean this up and let's look at the idea or let's look at what I can do on a particular day. Right, on a particular day, so this is my day. Okay, what can be my states? There can be one state where I have bought one. Other state can be I have sold one. Other state could be that I have bought two. Another state could be I have sold two. Right. These are the only 4 states on any day that I can have. There can be more, right? Which could be another state can be bought 0. So these are the different states that I can be on a given day, right? And it says we have to find at most two transactions. Now, for bot zero, we know max profit for that case would be zero if you didn't even buy anything. So we can ignore this. Like this, we know the answer for that. For all of these, let's figure out on every day. Uh, if I'm in a particular state, uh, if I'm in a particular state, what would be my profit, right? So I'm going to define four variables. First buy, first sell, second buy, and second sell. Now, and I allow the case where you buy and sell on the same day, which is essentially no profit, no loss, or something like that. Like that's okay. Now, so what do all of these signify? It signifies the current balance after at this state, right? So on a given particular day, what will be my balance? What will be my overall balance after first buy? Well, if my initial balance is zero, if I buy, then my balance is minus prices of I, right? Whatever price is on there. And if it's first sell, if I am first selling, and obviously you have to always consider the case where whatever was the like okay either this or the current value of first buy, right? Like I bought on some previous day and that's it, right? Then first sell. Okay, again similarly first sell, you will either continue the same value, whatever you had, or that means you already sold, and or there is a state where you have bought something and now you're trying to sell it. And so if you're selling it today, that means whatever your first buy is plus prices of buy, right? And now what about second buy? The second buy can only happen after second sell, right? Sorry, after first sell. So second buy is either you keep whatever your current value of second buy is, or you wanna take your second buys. It will be first sell minus second buy. Oh, minus prices of I, right? And what about second sell? Well, okay, whatever value there was, that means you've already sold on some other day, or you sell it on today. If you sell today, that would mean that you are in a state of second buy at some point, and then you sell today and get this much back, right? And finally, you will return second sell, right? And why it could also be because second cell will never be negative, and second cell B will never be. Um, it's the last state, right? And so that's fair. Like even if you don't actually do uh, two transactions, but because you're maintaining the maximum, like second cell will never be greater than, sorry, smaller than first cell, because well, it could just consider the case where you buy and sell on the same day, and so we're trying to get to a larger value. Now, one thing, we're taking this max everywhere, right? So max, max, max. So what do we initialize these values to, so that on the first day, right? So for that, I'm thinking of initializing the, so the first cell and second cell initializing to zero makes sense because you're doing plus something, so which is fine. But on the first by and second by, your balance can go to negative. So you'll take the largest negative value, right? So I'll take the first cell and second cell's initial value to minus infinity. All right, with all of this information, let's build the code. So we go for each before that. So let's first initialize these four things. First by equals to 0. Okay, first by equals to dot value. Or rather, let's just do for each price and prices. So for each price and prices, we're gonna do okay. Let's fix the okay. We use prices of I everywhere, so now let's use I then. And we run example test case. 6 and 4 are correct. Let's submit. Gets accepted. Let's move on to the last question. Again, it's on the same stock thing. So you're given integer array prices, where prices of I is the price of the given stock on the ith day, and an integer k. Find the maximum profit you can achieve. You may complete at most k transactions. So the change is now that earlier you could do at most two transactions. Now you can do at most k transactions. All right, let's move to whiteboard again, clean everything up. And let's look at a example. I think before I run an example, we just have to figure out, okay, so now this is max k transactions. So like in the previous question, we could returned second cell. Now we have to return uh, sort of cell of k, right? Or k minus one, whatever, in that sense. So let's build this by array and cell array, right? And what they represent is, so they represent balance after I buys, and this represents balance after I sells, and we need that information for every day, right? And when we return cell k information for the last day. But and we know while building this buy and sell for a specific day, we will need the previous one. So we won't really need, we only keep like one buy and one row array, and we'll keep updating the same guy. That's fair. So what's the logic that we're gonna build now? Let's see that. So the logic that we are sort of thinking, if I'm going to do buy of I, so if I buy, then my balance would be what? Uh, if I had, so this buy of I is, there is also like an old buy of I, an old buy of I, let's say we are reusing, right? So either I already have these many buys and that happens on some previous day, use that thing, or you buy today. And if I'm buying today, then I'm gonna have to do, I have sold I minus one, right? And now I'm buying another one. So now what about I equals to zero? So let's not handle I equals to zero. Let's just handle this from I equals to one to I equals to k. Fair enough. So we'll do, and similarly, cell of I would be max of, so either you already sold on some other day and that gives you most profit, or you're selling today. That means you have bought I minus one. No, you should have bought I, right? And then you're selling, yeah, so you bought I and now you sell, so you get this much money. And when I say bought I, that means you have bought I minus one and sold I minus one, and you bought another one, which is what the bought I means, and then prices of I is to you're selling today. Now, this I minus one is interesting, right? So that means what are you going to set your buy of zero and sell of zero to? Probably buy of zero means you've not bought anything. What's your profit? Shouldn't it be like zero? Yeah, I think both should be set to um, zero. Fair enough. That makes sense to me. Or we can just yeah, I think this is good. So let's build the logic based on this. So go back to code. So I'm gonna build these two arrays. So buy equals to new int of size k plus 1, and similarly sell equals to new int of size k plus 1. And we know that when you buy, a price reduce, so your overall balance might become negative. So you want to initialize, but not for buy of 0. Buy of, so now buy of 0 means you're not bought anything. So that should be fine, right? And sell has to be 0. I mean, initially we initialize it to 0, because when you're selling, you will never sell for a negative profit. That's just something you're not going to do. All right, so now for each price in prices, we're gonna go for each for int I equals to 0, or rather, yeah, it should be fine. I less than, or I equals to 1, I is less than equals to k, I plus plus, and you're gonna do this. So buy of I equals to max of buy of I comma sell of I minus 1 minus prices of I. Now this is a problem. No, I think this is good. Okay. And sell of I equals to max of sell of I comma sell of, sorry, buy of I, yes, that will make sense. So for every day, we are setting up this information that it's your first buy, so second buy, so third buy, so fourth buy, and so on, right? So for day equals to 1, for the first day itself, what does it mean for your 10th buy? Like, that would mean you have bought and sold. We're basically just considering uh, on the same day you buy, sell, buy, sell, buy, sell. That's the sort of thing that you're sort considering there, right? Exactly. So for the first day, for example, if we go from I equals to 1 to k, my buy of I would become minus whatever the price is, and my sell would become 0. And then if I do again, well, it will again be the same, you know. All the buys and sells would be exactly the same. On the second day, it might change, the third day, it might change. Makes sense. So let's, for an example, test cases. And it is wrong. Fair enough, it is wrong. And I think it's wrong because now this buy and sell, you set it up for that day. Now for the next day, your buy and sell are gonna change, right? So you have to do like a new buy and new sell. Um, and why is that? So because when we are saying this you can't use that, right? This is because this is initialized now to some garbage value or something. No, this, okay, let me try and understand. Um, so on the first day, it's all clear. I built the buy and sell array for the first day. Let me go back to, well, let me write it here itself. Actually, it has to be on based on day as well, right? So I have to do it's something like buy on this day, uh, a kth buy on this day. What would be the so it will have to be buy of by the previous day if I had bought k. This is one option, or by the previous day I had no. That is still this day. Till this day, if I'm buying, then I must have sold. So I must have sold on some previous day. So you're saying sell of what, d minus one? Yeah, by some previous day I had sold, and sold what? Sold k minus one, right? And I'm buying today, so plus prices of this makes sense to me. And selling on the sell would be what? Sell would be I've already sold k this, or I have buy bought k and I'm selling today. Sorry, okay, there is a slight mistake that I'll fix, but this is my general logic. So when I say this d minus 1, that's the old guy, right? So that's why I keep it as this. Because old is d minus 1, this is d minus 1 only, right? So initialize to d minus 1 only. Cell of d, I uh, could this cause a problem where like buy of I is utilizing cell of I minus 1, and then it's only utilizing the previous thing, so that should be fine again. But yeah, you bought one less, you have sold one less, and now you're selling the other guys, which is fine. Okay, I think the problem, it was correct only. I think I just made a mistake here. All right, run code. So we get 2, which is correct. Run example test cases. Do we get 7? Yeah, we do. So submit. And it gets accepted. All right, so this is fair. All stock related problems. Two of them are hard, but like both of them are exactly similar. If you to solve this, you could just put k equals to 2 to get to this one. And yeah, and we were trying to be efficient and solve the for the with the best space complexity. Like we saw the example where if I go back to like this one, Oops. Like essentially, we want it something to be like this, but we are instead of building like a 2D array, we just build a 1D array because we can see we can just reuse it and build for the next day because ultimately we just need the value for we just need this cell d of k at the end for the last day, last k, right? So we were able to just reuse the same 1D array and save on the space in that way. All right, that's it.